Good morning, all of you. Now I am going to discuss about the standard test signals. So, for modulation or any purpose, you need some signals. So, there are some signals which are standard and which are useful for our calculation and also to know about the performance of the control systems like this. So, the different types of standard signals are impulse, step, ramp, and parabolic. In that first one, unit impulse signal. So this unit impulse signal is given by the equation mathematically delta of t equal to 0 for t not equal to 0, and for from the integral 0 minus to 0 plus the value will always be 1. So if you observe this graph, this is the impulse response. If you take time on the x-axis, always the magnitude is 1 for t not equal to 0. Okay, next, unit step signal. So unit step signal indicates u of t is equal to 1 for t greater than or equal to 0. So other, if it is t is positive, always the value of the function is equal to 1, and if time is negative, the value of the function is equal to 0. So the graph will be like that. From 0 to infinite, the positive values u of t is equal to 1, and for negative values always u of t equal to 0. Unit ramp signal. So this unit ramp signal, it is defined mathematically by the equation r of t is equal to t for t greater than or equal to 0. And for t less than equal to 0, and for negative values the r of t will always be equal to 0. And for positive values it is equal to t, that means the slope is equal to 1. So it is directly proportional, r of t is directly proportional to time. This is the unit ramp signal. Unit parabolic signal. So the unit parabolic signal is defined mathematically by the equation p of t is equal to t square by 2 for t greater than or equal to 0. For positive values it is t square by 2, and for negative values it is 0. For t less than 0 it is equal to 0. So in this graph you can see for only the positive values of t you are getting the parabolic signal, and for the negative values you will be having 0. Next topic, modulation. So first of all, what is the modulation? So modulation means it is a process by which some characteristics, here the characteristics can be either amplitude or frequency or phase of the high frequency carrier wave is varied in accordance with the instantaneous value of message signal. That means there will be one carrier signal and there is one modulating signal. So modulating signal is the signal which is having the information which you need to transfer. So that signal is superimposed with the carrier signal, so that you will be getting the modulated signal. So that is nothing but this. The complete process is nothing but the modulation. In this modulation, first you can define the modulating signal as, this signal is also termed as message signal. That means it will be holding the information which you need to transfer. So the signal is also termed as a message signal. It holds the data that has to be transmitted, and so this is termed as the message signal. And next one is carrier signal. So carrier signal is always a high range of frequency signal. So this is high frequency signal. This is also called as high frequency signal, which is with specific amplitude and frequency. This should be having specific amplitude and frequency and phase levels. But it does not hold any data. Okay? The signal which is holding the data is called modulating signal, which does not hold any signal and which is used for the calculation transmission purpose. It is known as the carrier signal. So it is, carrier signal is also called as an empty signal because it does not have any information. So it is called empty signal also. And finally you will be getting the modulated signal. So the consequential signal that is obtained after the procedure of modulation is called the modulated signal. So this is the product of both the carrier as well as the modulating signals. So The types of the modulation are, so there are two different types of modulation. Those are continuous wave modulation, pulse modulation. So the continuous wave modulation, from the name itself you can say that the wave here used is of continuous form. So here the carrier wave is a sine wave, whereas here in the pulse modulation the carrier wave is a pulse waveform. So here you will be using carrier wave as a pulse signal. Here you will be using carrier signal as a continuous signal. So in this continuous wave modulation, there are two types of modulation: amplitude modulation, angle modulation. Again, this angle modulation is again classified into phase modulation and frequency modulation. Under the pulse modulation, there are two types: analog modulation, digital modulation. Again, this analog modulation is classified into PAM, PWM, PPM. PAM stands for pulse amplitude modulation, PWM stands for pulse width modulation, PPM stands for pulse position modulation. Under digital modulation, you will be having pulse code modulation. Coming to the first one, continuous wave modulation. As we have already said, in this continuous wave modulation, the carrier wave is a sine wave. So the sine wave is the carrier wave that modulates the message signal or data signal. So in this modulation, there are three parameters that can be altered. So what are those three parameters are? Amplitude, frequency, phase. If you modify the amplitude, then it is called as amplitude modulation. If you modify the frequency, then it is called frequency modulation. If you modify the phase, then it is called the phase modulation. Coming to the first one, amplitude modulation. So this amplitude modulation means the amplitude of the carrier wave is varied in proportional to the message signal. So suppose if you consider this is the wave which you are taking. So here you can see, observe, this is the information wave, that is this is the modulating signal, and the carrier signal is always the sine wave. It is always the sine wave. When you mix this modulating signal with the carrier signal, you will obtain the modulated signal. So here this is amplitude modulation. So you will be getting the amplitude signal here. So how it would be means, see, initially this information wave is drawn as it is, and the same wave is inversed here. It will be drawn like this, so that here you can observe the modulating signal here. This is the modulated signal. So this here the phase and the frequency, time period and the phase remains constant, but what is varying here is the amplitude. So amplitude of the wave is going to be varied, and the other remaining frequency and phase are kept constant in this amplitude modulation. Likewise, if you consider the frequency modulation, in this frequency modulation also you will be having the modulating signal and the carrier signal. Carrier signal is a sine wave and modulating signal is the information signal. And if you apply this frequency modulation, you will be getting the final signal like this. So you can observe you are using here a sine wave here. Here you can observe the frequency, the time period is very more. That is here. Here the frequency is here. You can observe the curves will be clumsy here. That means the time period is very small. So time period is small means that indicates frequency is more. Frequency is more. So for frequency modulation, the carrier wave, high frequency signal you will be using. So as high frequency is there, there is some output here. Okay. If there is less frequency indicates there is no output here. In this duration there is no output. But from here to here there is some information is there on that wave, it indicates. And here there is no information, and again here there is some information. So that means here you are giving here a signal here. So high indicates here there is some information, low indicates there is no information here. That means this is the frequency modulation. And the advantage of frequency modulation over an amplitude modulation is suppression of noise will be more in this frequency modulation. And the applications of this frequency modulation are these are used in radars, radios, telemetry systems, and so on. Okay, this is about the frequency modulation. And in phase modulation, here you can observe phase modulation means the remaining frequency as well as the amplitude will be constant. The varying quantity here is the phase. Phase angle is going to vary here. So you can observe here there is the information, and from here to when there is no information you can observe this the wave here is constant. I mean here there is a phase change here observe. This is the negative cycle. So from here again it is giving negative cycle only. Instead of going to positive cycle, it is showing again negative cycle has been started. That means the phase has been changed when there is a change in the modulating signal. Likewise, here completely there is no change, and again from here to here. So here the change in signal from is here to here. So that means the phase has been changed from this stage to this stage. So that means here the phase is changed and the remaining frequency and um, amplitude are remaining same. Okay, this is about the uh, continuous wave modulation. So what is modulation now? Modulation means you are superimposing a modulating signal. That means the signal which is having information is combined with the carrier signal so that you are obtaining the modulated signal. And different types of modulations are continuous wave modulation, pulse modulation. So in this continuous wave modulation, the carrier signal is continuous. That means here you are using a sine wave or any signal which is continuously varying with respect to time. You can take rectangular also, but the signal should be varying with respect to time. And whereas in pulse modulation, you will be considering a train of pulses. The carrier wave is nothing but a train of pulses. And in continuous wave modulation, you will be having three parameters who are going to change. Those are amplitude, frequency, phase. If you change the amplitude, then it is called amplitude modulation. If you change the frequency, then it is called frequency modulation. If you change the phase, then it is called the phase modulation. While changing the amplitude, the remaining two parameters, those are frequency and phase, remains constant. While in frequency modulation, the remaining amplitude and phase are constant. In phase modulation, the remaining amplitude and frequency are constant. Likewise, in the next class, you will be discussing about the pulse modulation.